Hi, welcome to my video introduction about how to prevent a car loan default crisis. So my project is about car loan defaults. America has over $1 trillion in car loan debt. So the goal of my project is to build a model that can accurately flag whether or not a loan is in trouble. And also to provide insights through model analysis and data analysis to financial institutions on what factors they should look at when determining whether a loan is in trouble or not. So data set and process. My data set was a Kaggle data set, which was basically Indian financial institution data of 200,000 rows and 41 initial features, where each row was a certain loan. The initial steps were data cleaning and data exploration, and one major issue was there was a class of balance of about 4-to-1 in favor of the non-defaulted loans. So in terms of modeling, I ran 6 different classification models. And my primary evaluation metric was F1 score, with the secondary being recall. The reason for this was because I wanted my F1 score to be high, so I felt that we were meeting a certain precision and recall value that was acceptable. But at the same time, recall was more the priority because I really wanted to minimize false negatives, which is predicting no default when they did default, which is obviously, in this case, the worst case. So in the end, I ended up choosing the decision tree as it received the best scores in both of these. And actually here on the left and the right, you can actually see the decision tree and its important features. So based on that, I decided to do a little more digging into my data, and I found that in terms of loans with large principals, there was a big difference in default rate between people with low risk and high risk. As you can see, the high risk group was much more likely to default. So I would recommend to institutions a high-risk loan is very likely to default, so, flag those. And in terms of age and number of delinquent accounts, we found that people in their low 20s to mid-20s and people in their mid-40s to high 50s had the highest default rates out of people in our data set. And I speculate this has to do with the fact that people in their low to mid-20s probably have student loan debt, as well as other commitments that they have to take care of on top of their car loans, as well as, it can be very difficult to get a first job and start making income, and then people in their mid-40s to high 40s probably have commitments such as a mortgage, possibly student debt of their children or other child care needs. So we would say, people in these age groups with delinquent accounts should be flagged as well. And so in the end, the final model did a great job of minimizing false negatives. As you can see here in the bottom left, this is the smallest number. However, this did come at a cost of a high number of false positives. For this business case, this was acceptable because false negatives were far worse than false positives. But in the future, I want to play around with this model and possibly more models that might be able to balance type 1 and type 2 error better. And that's my project. Thank you for your time.